Hi everyone. In this video, I am going to go over an example of an acid trapping problem that is from an old exam to try and clarify the process for figuring out ratios of concentrations between two different solutions or two different compartments within the body that have varying pH values. So first, I'm going to put the problem on the screen so that you can go ahead and read the problem and write down some key details, and then I'll go ahead and go forward with the explanation. So please go ahead and pause the video while the problem is on the screen here, and then we'll continue in just a few moments. Okay, so what I've done here is I've written down some of the key details. I have the drug pKa of 5.4, the plasma pH of 7.4, and the stomach pH of 1.4. And the question is asking, what is the concentration ratio between plasma and stomach? So the first step in solving this question is to determine the ion ratio between unionized and ionized in both of our compartments, in the plasma and in the stomach. To do this, we use the Henderson-Hasselbalch equation, which is pH equals pKa plus the log of our base over our acid. And when we use this equation, we can plug in our drug pKa of 5.4. We can plug in our pH, in this case plasma, of 7.4. And we can look at the ratio of our base to our acid. So if we solve this out, we get 2 equals log of the base over the acid. And that means that 10 to the second equals A over HA, or 100 equals A over HA. If we solve this out, we get 100 times HA equals A minus. What this tells us is that we have 100 times more ionized, or in this case A minus, in our plasma than we do unionized. So in the plasma, we have 100 to 1, and in this case it's 100 to 1 ionized to unionized. Okay? And if we do the same thing for our stomach, what we'll find is that stomach is going to be 1 ionized to 10,000 unionized. Okay, so what I like to do whenever I'm solving these is I like to first start by figuring out what the ratio of unionized to ionized is in our solution. And then what I like to do is I like to make a 2 by 2 table. So if we put plasma and stomach as our rows, and then if we do columns being ion and unionized. And if we set our plasma, as we found out, was 100 ionized to 1 unionized, and our stomach was 1 ionized to 10,000 unionized. Okay, so the final step in this is to realize that in equilibrium, what matters is our unionized form. Because the unionized form can flow between cell walls, this concentration always needs to be equal between our compartments in the body. So in this case, we would need to either multiply the entire plasma row by 10,000, or we need to divide the stomach row by 10,000. In other words, in our stomach, we currently have 10,000 molecules, but in our plasma, we currently only have 1. And so we need to do something to make those equal. So in this instance, what I'm going to do is I'm going to, for simplicity's sake, I'm going to take the stomach, and I'm going to do for the whole stomach, I'm going to multiply it by 1 over 10,000. Okay, and the reason I'm doing that is because, again, I want to make this unionized form equal to 1. Okay, so if we do this, what we get is our plasma stays the same, and it's 100 to 1. And our stomach now is only 0.0001 to 1. Okay, so effectively I've made our unionized equal the same concentration. Okay, so if we go back to our original question that was asked, the question is asking what is the drug concentration ratio between plasma and stomach? So in order to do this, we need to know what is the total amount of drug. Now the total amount of drug is the unionized plus the ionized. So to do this, all we need to do is add up our row. So in this case, for the plasma, we have a total of 101 molecules. And in the stomach, we have a total of 1.0001 molecules. Okay? And the question is just asking, what is the ratio between these two concentrations? So our ratio is going to be 101 to 1.0001. And this is going to be stomach. And this is the plasma. So in total, our ratio is about 100 to 1 plasma to stomach. And if you look at the answer on that answer sheet is going to be D. Okay? Hopefully this was helpful. The first step, again, is to find out what the ratio of ionized to unionized is. Make this 2x2 table here. Once you've made the 2x2 table, then the next step is, so once you've made this 2x2 table, the next step is to set each of the unionized to be the same amount. Then you add them across to get the total amount of ionized plus unionized, and you look at the ratio. So in this case, the ratio was 100 in the plasma to 1 in the stomach. Thank you so much for watching, and hopefully this was helpful.